same like the previous one. Okay, so and all these points that you see are points where you need to connect it to the this one. So here you are giving a power supply, this to this, because this part is isolated from the mains. So this to this, similarly here to here. So that will give the power supply into the input. Similarly here, this part it is disconnected over here. So take the smallest wires, tiny ones. Like these ones, the lower part. So when you do this, leave it, okay, leave the connection. Each point will have the nearby, whatever, the terminal where you will need to pin it, okay. There should be one more small one, I think all this will be. So the power supply will come now from both sides. Now you just have to see what meters they are. This is micrometer. Where is micrometer? Here. So connect those two. So this is positive. This is positive. This is negative. Never pull the wire, okay? Hold the red part. Don't pull like this. Hold this and pull. This is milliammeter. Milliammeter is here. Okay? Negative. It's very simple. Now the only problem is we had left out with only 1 voltmeter, but we will need two. So usually one will be kept constant and you will vary the other. So which needs to be kept constant, you first adjust off, remove it, connect it to the other one where the measurement has to be made. Okay. Now the important part is you will study 3 things: input characteristics, output characteristics and transfer. Now input characteristics means, keep in mind, in a transistor, this is common.
Common base.
You're doing common emitter now.
Yeah.
Common emitter we are doing. Okay. So this is your base, this is your collector, this is your emitter. So common emitter, CE configuration this is. CE configuration means base and emitter is taken as input, collector and emitter is taken as output. So if you are studying the input characteristics, first one, it means that you vary, you keep output voltage constant and you will change base emitter voltage VBE and you will see how much is the base current. Now this is an NPN junction. This is a PN junction. Base emitter is a PN junction. So what will happen? This will be like a normal diode characteristics. How we will do normal diode PN junction? After some 0.4 volts it will start conducting, no? This is a PN junction.
Yes.
Transistor is an NPN terminal. But input is only P and N. So when your input characteristics means you are changing VBE. That means input parts voltage and you are noting down what is the base current for it, which will be similar to that of a diode characteristics. Voltage and current in milliamps. But you should keep this as 5 volts fixed.
5 volt.
This will give only up to some 8.
Okay.
So we can do only one trial, 5 volt. In your comprehensive you have different things, 5 volts, 10 volts, 15 volts like that. We will do only one. So first what you will do, first you will connect this part, negative
To negative.
to negative, positive to positive. You will connect this. You don't remove this part. Wherever you have to remove the lower part only. This other end. Meters end, let it be on. Then you will switch it on. Before you switch on, minimize everything. And when you switch it on, you get everything as 0. Okay. Now what you will do, adjust this to 5 volts. Once this is adjusted to 5 volt, remove it. Not that part, this part. It will go 0 because you have removed. Now don't touch this knob at all. Negative is here. Now this will only show this VBE. So increase in steps of 0.1, 0.2, 0.3,
0.15 it is on.
0.2, 0.4,
Silicon.
0.57, it is becoming 1. It is starting there. Then like you want taking till it becomes up to some 70 or 80.
70.
It will go on increasing. 0.6, then you can take 0.7. See, it will jump now. It will start increasing very high. 0.8. After a certain period, the jump will be, the increase in the current will be high. You can go up to 100 over here. So up to 0.8 you can take. You can stop here. That's all. This is the input characteristics. Keep the output voltage as 5 volts. Change the input voltage and note down the input current. That's all. Clear? Any doubt?
No.
Minimize it. Now what we will do? We have to study output characteristics. Output characteristics means input part will be kept constant, but not voltage. We will keep
IB
Current.
IB as constant. So now we have to measure output voltage.
VCE.
VCE, output characteristics is VCE and IC. The B's are replaced by C. So for that, input part should be constant. So first you have to measure this one, no? So put it over here, because we will no longer use VCE now. Okay. So we will do 3 trials: 20 microamperes, 30 microampere, 40 microampere. So adjust this to 20. Any value, 3 values you have to take. It should make sure it is constant. That's 20. Now increase this in steps of 0.1, 0.2. If this becomes less, increase it.
So output node changing all those, only in input node changing the connections.
Output
Just put it to VC
That's
and
all.
that's it.
Nothing else you will change. We have only 1 meter, so you will change. Otherwise, if there were
If you
2
connect,
meters, you
if
don't
you
have
connect
to
this
change.
to an external one, then it's
That's all.
And when you increase this in steps, why does this decrease or increase?
Slightly,
If it decreases, you can
not
put back
just
20.
increase.
you have to give
Why
it
does
20
it
again.
Need not, maybe some reason inside.
Okay, now can you repeat what you did now?
Keep this as
As
constant.
how much?
20, 3 trials, 20, 30, 40 or 30, 40, 50, whatever. Okay, increase in steps of, if at all this goes
Oh,
down.
this is a 3 graph. That's
Yeah.
Now what you will see is, after some, now it started from 1. Okay. Whenever it is a digital circuit, it is, it will undergo fluctuations quite often. So make sure it is constant. Okay, so just keep this as 20. 1, 1. Initially it was 1, if you noticed. Then it will become 2. Then when I go on changing, it will become 3. Then it will become 4. But you see, after a point of time, how much ever I change,
Only 4.
this will be constant, because the current will become constant after a point of time.
So the graph is IB or
IB is equal to 20.
Output you are studying. Keeping input IB constant, you are changing output VCE and noting down the current. So here you will get VCE and IC for fixed values of IB. So next trial, I
For
will
30.
increase this to 30. And again I will repeat the same thing. In this case maximum was 4. Next case it may be 5. Again see, you should go slowly. So first you see for 0.1 you are getting 1. For 0.2 you are getting 3. You would
There
see
you can-
each reading. See, now afterwards whatever I do, it is going on. Okay, it goes up to 6. Any one reading, it will be constant for a longer period of time. So this is saturation current. Next one more trial. Make it 40. or 50, whatever. Do the same thing. Go on increasing. Here you will get up to some 9. That will be saturation. But you should find out 1 at what you will get, 2 at what you will get, like that dots.
That graph, yeah.
So you will get 3 graphs. This will be 4 volts means this will be 6 volts. This will be 9 volts for 3 characters. And the last one, transfer characteristics, again keep this part constant, 5 volts. Just change, go back to VC. VC is only, no? So keep this as 5 volt. You don't have to remove any connection. Keep this as 5 volts.
From output, the connection will be same.
Our connection you don't remove, just adjust this to 5 volts.
No, IB with IC.
Okay, adjust it to 5. Go on changing IB. So for 1,
0.1 it will be 10.
So let's say at 5 if it was 1, then at 10 it will become 2. Till 9 it will be 1 only. At 10 it will become 2. Next, at 15.
But how does this matter then? You can keep it at 10 also.
Any fixed voltage, that's all.
So that fixed voltage and this.
This you go on changing. This you will, what you will see is 1, 2, 3, 4 up to 5. At 5 it will start. Till here it will be 0, 0, 0. 6, 7, 8, 9. It will all be 1, 1, 1. When it becomes 10, it will become 2. Next, 11, 12, 13, 14, it will be 2 only. When it becomes 15, I have a class now. It will become 3. Next you can guess when it will become 4.
20.
At 20. So you will only note down these. So when you
4, 5 and 5 10.
5 2s are 10, 5 3s are
10. The slope of this will give you beta. The mistake you will do is here you have to include microampere, milliampere. So whatever slope you get into 10 power minus 3 divided by 10 power minus 6. So that 10 power 3 will come always. So it will be close to 200 current gain.
So I see
Output current to input current. Output voltage to input voltage is voltage gain. So current gain you already have, no? So resistance into the current will give you voltage gain.
Yeah.
According to Ohm's
But
law,
from
current
output
into
to
resistance will give you voltage.
transfer, no change.
Yeah.
So voltage gain means for what change in the input, what is the change in the output.
Hi.
So either you do like this. So you find the current gain, output resistance from the output characteristics, input resistance from the input characteristics you find out. Ratio of these two will give resistance gain. Resistance gain into current gain will give you voltage gain.
You have to calculate that.
Even if you don't get this value, it's okay. Current gain you find out, it's easy. But if they ask you for this one, you please remember. Okay, I need to go. I have a class now. Okay.
Thank you so much.